Hey students, this is your Professor O'Million Chuck, and today I'm going to be talking a little bit about scientific reasoning and whether or not it's value-laden. Alright, so what I'm going to be doing here is making videos for these two sections. So one video will encompass both of those, and then I'll put my lecture notes up next to this, marked PDF, so you can go over them and check them out. Okay, so today, let's see, I'm not going to talk about that. Let's go away. All right. Yeah, so, all right, so big question today is this, is scientific reasoning value-laden? All right, and so what I want you to do here is actually take a look at this video, right? It's a YouTube video. You click on the link, it should bring you to it. It's about James Hansen, and I'll give you just a moment to watch that here. Okay, so let's note that his initial data, right, one of the things that's interesting about the video, right, is that it could have been read as being consistent with natural variation, right, or the model that he had proposed. So he had, he had his models. He had like 3 different ones. There was the extreme one, the moderate one, and the not so bad one, right? And so the moderate one is kind of consistent with what we're observing nowadays in climate change. And I should also just say this up front, that we are assuming in this class that climate change is real, right? I'm not going to get into a scientific argument with y'all, right? That's just an assumption I'm going to make. If you disagree with that, that's fine. But listen, we're just going to work with that assumption so we can tease out some of the other issues that are going on in here. So I just wanted to say that before I got rolling here. Okay. Anyway, so James Hansen, he sounded the alarm about global warming in 1988, right? He was doing all kinds of modeling with NASA, and here he is before Congress, telling people, hey, things got to change. The first George Bush, he tried to respond positively, but of course the politics of climate change got rolling, and a lot of his ideas kind of got stymied. And so there he is. He's one of the first kind of people to be talking about this. And you saw in the video how many of his colleagues really praised him for being right. He had taken this risk, okay, and he's turned out to be correct. But here's the question I kind of want to pose to you all here is, why did he testify before Congress about human-made climate change when he could have been so wrong, right? I mean, if his model could have just been predicted by natural variation rather than by the hypothesis that he was stipulating, wouldn't that have just been kind of catastrophic for his career? He would become one of these people, in a long line of alarmists. Right, that people in the 60s and 70s were sounding the alarm about overpopulation, and that the world would no longer be able to sustain the human race by 1975. This kind of stuff is just, you can find this all over the place. And now we kind of laugh and go, well, that's sorry, buddy, you didn't take into account all sorts of things. So here's the deal. Shouldn't he have waited for more evidence to come in? Why did he take a risk, right? And this gets us into the paper that I had you read today. Now, this paper is an old paper. Okay, it's from 1953, I believe. This is Hudson's paper here, and he cites Rudner. And you know what? Never mind. Let's just get back to this. I can actually click on the link here and bring it up. And it is, yes, a 1953 paper. So there it is. Right, so it's an old paper, and it's kind of a classic. All right, it's got, I love this old script font, and I'll be honest with you, it's not the most exciting read. It's kind of abstruse. He's addressing much of what he has to say to these guys named Quine and Carnap, right? And if you haven't heard of them, well, you haven't really taken much philosophy, and you haven't studied high-level metaphysics. And he's talking about things like ontological commitments and choosing language systems, and you're just like, oh my goodness, what on earth are you talking about? And for purposes of this class, we're just going to ignore that debate entirely, but just extract the very important point that he was trying to make, all right? And that is this right here, is that our decisions regarding the evidence in respecting how strong is strong enough, right, to accept an hypothesis is going to be a function of the importance, and he says in the typically ethical sense, of making a mistake in accepting or rejecting the hypothesis. All right, so that's his big idea, right? And it's a really big idea, and it's kind of a game changer kind of paper, right? This paper is often cited in at least by the advocates of those who think that science is a value-laden enterprise. And when I say value-laden, I'm talking about scientific reasoning itself, right? The very kind of essence of inquiry, in which we're kind of, okay, we're testing hypothesis, we have our evidence, we have our data, and then there's some kind of statistical issues here about probability, but then we just then we got to make this binary choice of accepting it or rejecting it, right? And he thinks, right, that's very much a function of our ethics, and that has to do with the consequences that could occur if we're wrong, right? So, all right. So anyway, this kind of leads us to the uncertainty argument, right? This is something that value-laden advocates of scientific reasoning like to make. It's one of the arguments. Okay, there's a couple other ones that they make. But this one I think is one of the most interesting, and so I want to go over it in this class, right? So premise 1 says that the scientist, qua-scientist, right? What does that little qua mean? All right, let's just kind of pause right there for a second. What that means is that the scientist, operating in the capacity of a scientist, right, acting as a scientist, right? So there's a kind of function, there's a proper function that scientists play, there's a role that they play. So the scientist, guy wearing white lab coat, or girl, as the case may be, acts as a scientist by accepting or rejecting a hypothesis, right? That's what they do. That's part of their function. They have to accept or reject hypotheses. It's just what it means to do science, okay? Now, premise 2 says this: no amount of evidence ever completely confirms or disconfirms any empirical hypothesis, but only renders it more or less probable. Okay, so this is the idea that all scientific claims are tentative, right? And it's hard to kind of understand exactly what this means. I mean, scientists can say some pretty bold and certain things, and so what do you mean that they're all tentative? And I think the idea is basically this: is that even if our ideas, our scientific ideas, we're really certain of them, it is like theoretically possible that some new evidence could come into our field of view that overturns what we are just totally certain of, right? And in the history of scientific discovery or scientific thinking, kind of looks like this, right? If you get into the philosophy of science, you get into the different ideas about how people are making sense of the world, and people are really certain of certain things, right? Like geocentrism, like there's one. And along comes, right, some extra evidence that we hadn't seen before, and it overturns this. So that's the kind of idea that's at work there. It's kind of like the tentative theory of scientific evidence, right? Everything is kind of tentative. So, we can debate that some other time. But let's just think about number 3 now. Now, the consequences of 1 and 2 leave the scientist in a position to decide how high the probability of a hypothesis relative to the evidence must be before they're warranted in accepting it. Okay, so they have to decide, how high does the probability got to be, right? So, is it going to be like 80%, 90%, 95%? Okay, there's going to be that kind of evaluation. We have to figure that out. And it could be, it could be the other way too. It could be below 50%. There are certain ideas, there are certain tests for cancer. Right? You run a test for cancer. It might be a minor, easy to apply test, and maybe it's only like, I don't know, 20% right or something. Okay. Well, you might go on to get further tests in light of a positive, right? And it might be a false positive, okay, because it's only 20% right, but you really kind of want to make sure that you don't have cancer, so you go on to get further testing, okay? That's like an illustration of premise 3. Then premise 4, the decision required in 3 is a function of how important it will be if a mistake is made in accepting or rejecting a hypothesis. Okay, so if a mistake is made, right, and there's bad things that happen in light of that mistake, right? So suppose you just ignore the test of cancer, okay, and you're just like, well, whatever, it's only 20% right, who cares, you know, and then it turns out you do have cancer, right, and then you discover it at a later time, which could affect your treatment options, all right? So you can kind of see how you might think, well, you know, if it's only like 20% and it's a false positive, you still might follow up on it anyway, just because, you know, what if you're within that 20% range of, you know, actually having a true positive? So at any rate, that's what number 4 is saying there. Okay, so if 4 is true, then scientific reasoning is value-laden. Therefore, scientific reasoning is value-laden. Okay, that's the uncertainty argument in a nutshell. Now, a key assumption here in premise 4, of course, it has to do with ethical connotations. We saw that with Rudner's idea. It has to do with consequences, right? So our consequentialist moral theory that we were talking about is an important one, okay? What are the outcomes at stake, right? If a scientific hypothesis is accepted or rejected, okay? We have to kind of take account of that, right? That is part of consequentialist reasoning, right? We can't just do these things and not think of outcomes. Now, it doesn't have to be only outcomes that matter, but they have to matter quite a bit, all right? So that is something that is important to understand about why it is value-laden, right? Because we are making sense of outcomes and we are taking them very, very seriously, okay? All right, big idea. The amount of evidence needed to act is partly determined by how dire the consequences will be if we're wrong. Yes, just said that, okay? So implication, right, for Hansen at least, the consequences of him staying silent and waiting for more data to come in were judged to be worse than sounding a false alarm. And that's something he probably thought through. You know, I don't know his story super well, but that is kind of the idea here, right? And you can kind of go through just different cases where you might think this is the case, right? You know, you might think of the people who were testing the water in Flint, Michigan. Okay, that's another big case that's just recent. You know, how much evidence did you need, right, in order to sound the alarm? And it turns out, you know, you didn't need that much. And then they had a whole overwhelming data set after just some inquiry after a few months. Okay, so anyway, I want you to think about this argument. What do you think of it? Is it a good one? Are all the premises true? Right? What do you think of these premises? Are they correct? Right? Those are the questions I want you to kind of be thinking about. Right? Is this the function of scientists? Right? Is this true here? Okay, and then you might be thinking about this one as well, right? And that, you know, just think about all of those, right? Okay, so that is the case for the uncertainty argument. The uncertainty argument makes use of this really interesting idea called pragmatic encroachment, right? And it's the idea that our beliefs or knowledge can justifiably vary given the same amount of evidence, though appearing in different circumstances regarding the stakes of our beliefs, right, and what they're related to. All right, so here's an illustration of this idea. I know that sounds kind of abstract, and I got to harken back to the olden days here, okay? So I don't know, y'all probably use your smartphones to deposit checks. Even if you get checks, I don't know if you even get checks anymore. Everything gets just direct deposited. You know, these old philosophy cases, they just, you know, they harken back to a different era. Anyway, it's Friday and you're driving home and you got a check that you got paid or something, and you want to deposit it at the bank, right? So this is the era before all of our good technology banks, right? This is when brick and mortar banks really mattered, okay? But here's the thing, there's a long line, and you know, it's the end of the day, you've had a tough day at work, you don't want to stand in line at a bank, that's just so boring. Again, you don't have a smartphone, you can't play Candy Crush, And so what you tell your wife or your husband or whoever, you just say, you know what? I'm going to do this Saturday. Okay, I'm going to do this Saturday. But she says the hours of the bank might change. And they've been known to change. You know, there are times you've gone there and it hasn't been open. Okay, but you know, you tell her not to worry because you were just there 2 weeks ago and you saw a sign that said, hey, they're going to be open from 9 to noon. So you wait. You know, they don't change that much and that often. So, you know, you just wait and you don't deposit the check right away. You wait till Saturday morning. Okay, so that's case 1. Case 2 is just like case 1, except there's an additional issue here. You gotta accept. You gotta deposit that check because a very important payment is required out of your account by Monday. Right now, if you don't make that payment, you know, you and your family are gonna be in trouble. Right? You're gonna suffer terribly. Maybe you'll get evicted or. You know, I don't know. Okay, so what you do is you stop then and you wait in line. Okay, because the same objection is raised by your wife. Well, you know, yeah, but Saturday, you know, yeah, you've been there 2 weeks ago, but bank, you know, the hours change, and you know, you're just not going to take any chances, and so you wait in line. Okay, so in both cases, right? In both cases, your evidence remains exactly the same, but you believe and act differently. Okay, so you accept the hypothesis that the bank will be open in case 1, but not in case 2. And that's kind of a funny thing, right? You have the same exact evidence, but in case 1, you take yourself to know that everything's going to be fine. We'll wait. In the second case, you don't take yourself to know, and so you go. I'm sorry. You stop and wait in line. Here you don't. You just go home. Did I say something different? All right. Okay. Yeah. So you wait till Saturday to do it. Stop, wait in line. Anyway, okay. So I don't know. That's the question I want to pose to you here for reflection. Do you think that both of those beliefs are rational? Okay. Even though you have the same amount of evidence, do you think that these pragmatic concerns can shape our knowledge? Right. Now, if you do think that that's rational, right? Well, then you do think pragmatic concerns can shape whether or not you have knowledge or determine whether you have knowledge. Right, so let me know what you think about that. That's an important question. And we will then kind of take a look here now at objections and replies to the uncertainty argument, okay? So one objection is to say that premise 2 is false. All right, so that tentative idea, everything is tentative. Okay, you could probably furnish examples of things that are called settled science. Right, settled science. These are things where you know, the empirical evidence just has confirmed the hypothesis. So, for example, the Earth orbits the Sun. Okay, that's pretty settled. Right? It's hard to dispute that. It's hard to imagine the way a world could be, the world that we live in, where new evidence comes along and just overturns that. I mean, how could that possibly be the case? All right. And so premise 2, that just seems dumb. Why think that? Right? There is such a thing as settled science, and it seems that settled science should very much be determined by empirical evidence, and that's that, and we don't need to worry about values or anything like that. Okay? And I think the purveyor of the uncertainty argument here, the reply, is to actually kind of admit this and say, you know what, yeah, I think that's right. We can make that distinction. But then let's also remember that we are doing things like cutting edge research. So think of James Hansen and his cutting edge research into climate science and climate modeling, and the hypothesis of global warming and the catastrophes that could result from that, right? You know, people still think that's very controversial, that it's not settled. All right, now that's changed. A lot of people do think it's settled. All right, but back in the 80s, it wasn't that way. I remember even talking about this in school, and people just didn't really know what to think. Right, cutting edge science, right, isn't something that is settled, and so values are part of how things get worked out. All right. All right. Objection 2: acknowledging that science is value-laden is going to undermine the authority of science and make scientists into alarmists like everybody else. All right. Okay, you can kind of see how this goes, right? It turns scientists into activists, right? And you know, activist scientists, you know, they when they're activists, they're just no longer acting like scientists, right? You know, part of inquiry is following evidence where it leads, and if you don't have enough evidence to get to where you want to go, and you start going where you want to go, well, now what you're doing is advocating an alarm, and you're being an alarmist. And you know, James Hansen was certainly called that. All right. And the answer to this kind of objection to say, well, not if we're transparent about our goals and values. Okay, so what we could say is like, hey, look, all right, there's a value judgment here, right? But it's reasonable, okay? If we're wrong about this, right? Well, then what's so bad? I mean, think about climate change, all right? So we start kind of like making our cars more fuel efficient, right? We start relying on non-fossil fuel energy sources, and oh, guess what, guys? The planet's not warming, and we're not causing it, and we're not causing catastrophes, but big deal, right? What we've done here is made things more efficient. We've made things cleaner. We've created different jobs, different technologies. What's so bad about this? Okay, there's that kind of like thinking, and suppose that we are right about this. Well, you know, then now we're making headway against this thing, and in fact, we probably need to make more headway. All right, so if you're transparent about your goal here, it doesn't seem like there's any real problem. All right. Objection 3: not all science is like climate science, where the consequences of accepting or rejecting a hypothesis are severe. That's true, right? You think of like physics and chemistry and what's going on in those things, all right? You know, the consequences of making a decision about some of those issues just isn't going to matter as much, right? But decisions still need to be made about how much evidence is needed for a hypothesis to be accepted, all right? And so if it's a cutting-edge research, right, maybe you're thinking about, I don't know, splitting the atom, okay? You might have to kind of make some value judgments about how, how much evidence is going to be needed for your hypothesis, right? Again, right, maybe you don't need a lot, right? Maybe you don't need to, maybe the statistical certainty is high enough where you don't have to make a value judgment. But if it's cutting edge, well, maybe you do. All right, so that's how the uncertainty argument works. You can think about that, whether or not these are good objections or they're bad, right? That's something you can reflect upon in your reflection for the week. And now we're going to turn to a defense of the value-free model. All right, so let's get into the value-free model here. Let's talk about this a little bit. Let's see if I can't precisely get this where I want it to go. I don't want to get too far ahead of myself. All right, so we're talking about Hudson's paper, and I have Hudson's paper open here, and it's a recent one. Okay, this one's published in 2016. So the value-laden model of science based off of the uncertainty argument and some other ones, have really been, influential. Okay, there's a lot of people who think that scientific reasoning is value-laden. I don't know if scientists think that way, but that's the way philosophers of scientists have thought. And, large part is due to this article and some other ones. But Hudson comes along here and he just says, I don't know about that, okay? And let's see why. What's going on in his paper. I think the main idea that he wants to communicate here is that the value-free ideal is a normative ideal that scientists strive to attain. Okay, so this is a kind of ideal. All right, this is what we want. Maybe we won't get there. Okay, maybe we won't get there, but that's where we want to be. All right, so it's a norm. It's not something that may be actual, but it's something that in science utopia, this is what we want. Right? This is when scientists is operating and functioning correctly. Yes, in the messiness of human life, values might enter into things, all right, but what we want, and if we want perfect science, right, perfect science is done in a value-free way. Okay, so look, it may be true that a hypothesis is going to be held for, value style reasons, but it is epistemically preferable. All right, let's think about that. When you see stuff like this, right, epistemic, right, epistema, I think that's a Greek word that is referring to knowledge or knows, all right? And what the deal is here is that in terms of how we want our knowledge to work, how we want our procedure of reason to work, especially in science, it's preferable if our hypothesis is held for reasons that have to do with evidence and not values, okay? And that's what we expect scientists to do in their work, right? We want them to achieve that ideal. Now, maybe that's impossible, but to approximate that ideal as much as possible ought to be the goal, okay? And I think that's Hudson's big claim here, and it's an interesting claim. And I think it's one that's really worth exploring here, right? So here's the deal. I think that he zeroes in basically on premise 4 of the uncertainty argument, right? So just to repeat that premise there, it says the decision required in premise 3 is a function of how important it will be if a mistake is made in accepting or rejecting a hypothesis, right? Determining how much evidence you need is a function of how important it will be if a mistake is made. But he has this little story to tell, okay? And it's a kind of boring story. It's not very interesting, but I think it is one especially, right? Suppose you're working in some pharmaceutical company's lab and you're trying to derive at a safety decision about a drug, right? Now you're aware of two facts. The drug is meant to help children, and it's got to meet, there's this government safety regulation, right, that requires the incidence of adverse effects to be under a certain level, okay? So you're aware of those two facts. It's for children, it's got to meet this regulation. But now suppose that in light of these two facts, the scientist accepts the hypothesis that the drug is safe for children. Scientist runs the test, determines that the drug is safe, and that's just the end of story, okay? Right? So where the heck is this consideration of a mistake entering into the decision procedure to accept the hypothesis or not? He doesn't think there is one, right? There's just no place this enters in. The scientist only needs to define safety in terms of the regulation and then determine empirically whether the drug meets the regulation. Okay? All right, so we might think a little bit about, well, okay, how do you do this, right? If you can't ever be certain that it's meeting the regulation, right? And if you only get close enough, well, what defines close enough, okay? However, he just has to say this: whether the regulation is good or bad for children or children are valuable, right? These things just stand independently from this line of reasoning, right? Again, I'm not sure he gets past this piece, like how did you determine whether the drug meets the regulation? But it might be just a really straightforward process, okay? It might not be really daring, okay? So maybe we can assume that. He isn't exactly clear about that, but I think that's what he has in mind. And so you think, well, let's just ask this: does Hudson have a point here? Or is it too trivial to worry about? Okay? This does matter a lot when it comes to, especially like EPA regulations. Okay, so you might have, again, the Flint water crisis. There's a certain level, that's accepted by the EPA of lead in water. I think it's like 15 parts per billion or something like that, right? And then above that, things are actionable. Well, a scientist can just run a test and say, all right, do we have 15 parts per billion? Nope. Okay, so no action. Now, you might think that regulation is dumb for various reasons, okay, but here in this kind of thing, you just don't have, right, this big kind of gamble being taken or something like that, all right? So the question is, does Hudson have a point here? Is it too trivial to worry about? All right. Now, there's some objections to Hudson's paper. I'm going to go over these kind of quickly because I kind of want this lecture to end at least in a good amount of time here, right? But, there are people who think, right, the value-laden people, they even think that the heliocentrism and geocentrism debate, when it was being played out, was one in which values played a role, All right, so yes, we can look back now with, the hindsight and 2020 vision that we have with that. But at the time, values played a role, right? Consistency within external theological authorities, that was pretty important back then. And then, of course, there was simplicity and elegance. We got rid of the epicycles that were part of the Ptolemaic, I can never pronounce the guy's name, the old view, right? The geocentric view, the Ptolemaic astronomy. There we go. So the reply was that for Hudson, right, he's going to say something like, well, the scientist doesn't need to value either of these things, okay? Consistency with theological authorities, whatever. You know what? Simplicity and elegance is really interesting from a mathematical perspective and a logical perspective and why it kind of matters. But a scientist doesn't have to be committed to this. I mean, it just really doesn't. All you need to do is just have the right kind of evidence. It just tells you that, well, look, the Earth is going around the sun, all right? And so you don't have to be guided by these things in order to be to get to the conclusion. Right? What about cutting edge research? Right? What about that? Okay, you don't have certain things like, hold on a second here. You don't have these things like these ancillary guides, like regulations from the government, right? You don't have like, oh, is it meeting like this standard that's been set by a policy? You don't have that. Well, cutting edge research is just really open-ended, but look, the reply is that value judgments may enter into it. Okay, so James Hansen, he made his value judgment, right? But the idea here is that that's unfortunate that he has to do that. Okay, it's unfortunate, and that's something that we should seek to remedy, right? So more time has to pass, more research has to pass, more evidence, more data has to come in order for us to say, right, that climate change is being caused by human beings, right? For that to be a truly scientific idea. Right, and the bar is high here, okay? Hansen, it turns out that he was right, okay? But at the time, he was kind of taking a gamble, and his claim was a scientific one, and it was open to certain testing. It could have been refuted and falsified, right? And that's what we were doing. We went through that process, and now we're kind of in a position to now say, things are looking pretty bad on the global warming front. Okay. You might think that the value free is just that ideal. It's just too demanding. That's another objection. Okay. In fact, you might think it undermines the authority of science to justify change in policy actions. Right. So maybe Hansen should have been more of an idealist, and he should have said, okay, well, I'm just going to kind of back off here, right? And I'm not going to issue my warnings. Right? And that just seems to be kind of like, well, doesn't that kind of defeat, right, some of the purpose of science here? Don't we want scientists to kind of challenge the status quo, right? And the reply here is that, look, scientists don't always have to act in the capacity of scientists, right? They can become advocates, right? And look, they can be very reasonable advocates, right? Because they have some scientific evidence on their side. Now, is it, 100% determinative? No. Okay. Is it subject to peer review and testing? Of course. All right. But it's okay to become an advocate, right? And a scientist can wear two different hats, right? So that's the idea behind the value-free model. I know that's kind of a crash course, but I hope this helps make sense of what's going on in these papers and how we can think about things like pragmatic encroachment and how these things, pragmatic concerns, shape our beliefs and knowledge and that kind of stuff like that. So if you have questions, I know some of this is kind of difficult material. You can kind of work these out in our discussion, in our reflection, and I'll be posting some a discussion guide to help you kind of figure out how to post your reflections. All right, so email me if you have questions. I'd love to answer them, do the best that I can, and I will talk to you later.